I'm sure you all heard of this term out of Africa. Basically, almost all the evidence we have suggests that the origin of our species and many of our ancestors, the hominins, happened in Africa, and then there was a diaspora or migrations out of it. So the out of Africa is a common phrase used across. Let's revisit it like we did before, going at the timeline of hominin evolutions, time going down here. 4 million years ago, we have evidence of Australopithecus anamensis, our ancestors, Australopithecus afarensis, and there is evidence of coexistence of Kenyanthropus platypus, and then various other lineages that evolved, Africanus and Ethiopiticus boise and Australopithecus gari, Sediba, robustus. We looked at this before, and then at some time there is a co-evolution of the Homo lineage, so Homo habilis, Rhodophensis, and they all existed for certain amount of periods. So you can see Homo naledi existed for much longer than all these other species as shown here. Homo erectus existed as well, and Homo neanderthalensis. We saw already how Homo heidelbergensis led to speciation and expansion of the habitats, including the Homo sapiens. So along the way we have had Homo ergaster, and the question of course is, were they only remaining in Africa or going out of Africa as well? And if so, what was driving this migration out of Africa? So looking at location of hominin fossil deposits again, we have also seen this before, this time time going from bottom to top. So the sites Ethiopia, Chad, Kenya, Tanzania, and South Africa. So remaining within Africa, looking at again these various lineages starting from way back here. Again, Australopithecus, Ardipithecus, and so on, coming towards more modern times. And you can see how all the species of hominins disappeared at some point, and you can see the locations. We'll come back a little bit later on and see that there are evidences used to see if they were socially connected, especially more further into more recent times. Okay, so we're only dealing with hominin fossils, so we don't have the Homo lineages listed here. So you have the various Australopithecus, Ardipithecus, and we don't show Kenyanthropus and Paranthropus here either. So there is big climate changes that happened around here that we will revisit. That's the Pliocene, Pleistocene boundary, and then more recently the changes in time scales of ice ages and so on, which we will look at a little bit later in this chapter and come back to in more details in the next chapter. So somewhere here you came to the end of Pliocene, where the sea surface temperature in the Pacific were very different. Climate over East Africa, where a lot of these sites exist, where it was very different. Lush green forests, and somewhere in this range of 1.8 to 3-4 million years, climate changed. East Africa got aridified, and then, as we have discussed before, bipedalism presumably evolved because of that, but we are here talking about anatomically modern human beings already. So we have to think about anatomically modern, not human beings, anatomically modern homos, let's say humans, walking upright, bipedal, spinal connection, cranium size. As we have seen, cranium did grow along here all the way into Neanderthals and sapiens. Along the way, Homo erectus, Homo habilis, and so on. And we have to look at behaviorally modern humans, language, communication, tool building, and also maybe functionally modern in terms of ability to make more precise tools and so on. Maybe there is social behavior that is different along the way as well. As we have said, the definition of modern human is not tremendously robust or strict, but it is important because there have been changes along the way. So if you look at the timings, so we again go back to hominin tools and hominin fossils. So tools, as we'll come back to again and again, are used as evidences for how we got better in terms of using opposable thumbs, in terms of making tools that were designed to be thrown far with spears, to be more precise in killing, etc., as opposed to the original Paleolithic tools going back to earlier times of 2 or 3 million years ago, when our ancestors were using stone tools as well, but they were using what were available. They may have been sharp, light enough to be thrown and so on, but they were not specifically designed to be anything more precise, whereas the technology kept growing till the Neolithic, which is literally at the beginning of the Holocene, and then of course came Iron Age, Bronze Age, and Bronze Age, and so on and so forth. But what needs to be explained also is the locations of these hominins all across. So you have Olduvai, which we already looked at in Tanzania 1.9 million years ago in terms of hominin stone tools and hominin fossils, and even older ones here in Turkana, Kenya, so 2.1 to 3.3, Lady Garau in Ethiopia 2.8 million years, and you get progressively younger, but there are also some older ones here, 1.85, 1.78. So again, tools and fossils. Shanghai, China, much more recently getting into older and older species. So 2.1 million years here, 1.66, and all the way down here as well in Indonesia, 1.5 million years. So the idea is to explain why Europe had arrival of some of the hominins, especially the Homo species, much later than all the way into China and so on. That has to be explained properly, and what would have driven the migrations out of Africa, or whether there were independent evolutions happening elsewhere. That hypothesis of independent evolution, I think, is pretty much discarded, especially because of very different climates, and the genetic similarities would indicate that there is a lineage that comes out of Africa, even though we know that Neanderthals may have been arisen out of Africa independently, but from another Homo lineage like Heidelbergensis, right? That's where the speciation happened, as we saw before. So the timings, the distributions, and the drivers of the migration and the paths, because there is evidence that there was migration out of Africa as well as migration back. So climate has changed along the way, especially during these times. We have had 8 or 9 ice ages, and we will see that again, and there have been abrupt changes as well along the way, and massive changes in sea level, as we saw an example of the last glacial maximum where these pathways would have changed a lot. And then we don't know when the seafaring and boat technology would have evolved, and how humans would have colonized later on, for example, the Americas, much more later than these, much more recently than these. So these kind of questions remain, but all the evidences are listed in a large number of references in the book throughout the chapter, and it looks at each of these regions separately, with each of the papers corresponding to those regions and the kind of evidences that exist. So if you look a little bit more carefully here, some key early fossils of Homo sapiens. So we are now getting away from our hominin ancestors, coming closer to Homo sapiens. So we are coming much more closer now into 250,000 years or so. So and related key species in Africa and Eurasia. Harvati et al. Present their analysis of 2 fossil skulls from Epidema cave in Greece. So we are looking at we don't show Greece here. Here, for example, Epidema, Greece, 210 kilo year, earliest known European Homo sapiens, 170,000 kilo years. So why is it a delay from here to here? Why is it earlier here than here, for example? Those are not easily explained. Okay, they report that fossil Epidema 1 is an Homo sapiens species that is at least 210,000 years old, from a time when Neanderthals occupied many European sites. Here, it is the earliest known example of Homo sapiens in Europe. Okay, so why is it not older compared to these places? Okay, where was I? Harvati and colleagues confirmed that, as previously reported, Epidema 2 is Neanderthal specimen, and they estimate that it is at least 170,000 years old. The author's findings, along with other discoveries of which a selection is shown here, shed light on the timing and locations of early successful and failed dispersals out of Africa hominins, modern humans, and other human relatives such as Neanderthals and Denisovans. And the dates are in kilo years. So Denisovans are up here in a Russian cave. So we will see later on that genetic evidences are now being combined. That's where the term bottleneck comes from. So here are Neanderthal presence 450,000 years to 35,000 years ago, and we have already discussed a little about why they would have disappeared, whether they just merged genetically with modern humans that came along later, or did they battle humans and lost because their cranium brain size was big but their cognitive abilities were lower, and so on. So you can see the various numbers here. South Africa 260 kilo years, so we're talking about Homo sapiens, hominin possibly related to Homo sapiens, Neanderthals, Denisovans, which we discussed as a separate lineage, hominin not assigned species as well, present in some places like here in China, Dali. So there is even now difference in genetic materials in northern China and southern China. Koreans, for example, are more related to northern China than southern China, which makes sense, and Japanese are related to various immigrants or migrations and diasporas from here. So just looking at these kind of numbers with available evidences, it isn't always clear whether out of Africa is the only hypothesis that works, or there are other explanations that will continue to emerge. So if you look at sites of important hominid excavations, they again are all over the place, including the older ones like Australopithecus, Homo habilis, Homo erectus, and Homo sapiens neanderthalensis, and Homo sapiens sapiens, us, and sites of other fossils not definitely identified here. So obviously the pathways are important and drivers are important, as we said. What is the bottleneck that I mentioned in the title? Basically, when you have a parent population with significant genetic variation, there can be a physical, geographical bottleneck that constricts the spread of the genetic material, or one particular group of a genetic mix breeds much more than others, so some kind of a bottlenecking event happens and you end up with what is called genetic drift. So post-bottleneck population where all but the green and yellow alleles have been lost, so the red and other purplish colors and blue colors are all lost due to this bottleneck event. Okay, so this is an example used to look at the bottleneck among the cheetahs, for example. A genetic bottleneck occurs when a population is greatly reduced in size. The bottleneck limits the genetic diversity of the species because only a small part of the original population survives for whatever reason. With a greatly reduced gene pool, the remaining members members of the species may have trouble adapting to a new environmental conditions. You may lose certain adaptations, such as climate change. A genetic bottleneck can be caused by a number of factors, including natural disasters, overhunting, or habitat destruction. Now we are talking specifically about cheetahs. So here, scientists believe cheetahs have already survived the latest two genetic bottleneck events. India, for example, is introducing cheetahs now because they disappeared a long time ago. Only leopards are left. So the first event occurred about 100,000 years ago, which when cheetahs left Americas to spread out across multiple continents. This left only a small pockets of cheetah populations which were too far apart from each other to interbreed. So 100,000 years ago there was one bottleneck that reduced the genetic diversity. Second event was about 11,000 years ago, which sounds familiar in terms of the end of the last glacial maximum, when many of the Earth's large mammals became extinct. At that time, the cheetah populations in both North America and Europe died out, and the scientists believe as few as 7 cheetahs survived in Africa. Imagine, they were down to just 7. That was 11,000 years ago. Cheetahs eventually made a remarkable comeback. The cheetah population grew to over 100,000 cheetahs by the 19th century, but stress from both human presence and faulty genes have caused their population to dwindle to fewer than 8,000 today. With decreased numbers, cheetahs could be heading towards another genetic bottleneck. So are we heading there? So moving them into India, for example, is a way to also give them new geographical region where the bottleneck can be eased. If they have lost the genetic material to survive, then that has to be seen. But this is a Darwinian experiment where humans are doing something. The other thing, maybe I should leave this podcast here, but you get the idea that we have to take all the evidences we collect about presence of hominins and hominidae like Australopithecus and others. Well, I shouldn't mix the great apes with that, but taking all the evidence and trying to figure out various factors like climate drivers, bottlenecks, genetic drifts, and the climate drivers of immigration out and immigration back, and so on and so forth. So obviously it's clear that evidences, fossil evidences, tool evidences, genetic evidences have been found across the globe. Now it's a question of having to explain it. Okay, and if the number of cheetahs had dropped down to just 7, it is also argued in one of the papers that maybe as few as 80 early Homo sapiens arrived in North Americas and populated the New World as it stands now. So how populations dwindle down and recover. There is also some evidence that maybe even in Africa Homo population had dropped to as few as 10,000 because of resource limitations and other issues, and then it recovered. So these are narratives that exist based on evidences, but as we saw, uncertainties tend to be large as well. So I'll continue this in the next podcast and add a few more points, and I'll come to giving some climate background to many of these things. Okay.